water, earth, fire, air. Long ago, the two physics nerds were planning a wedding. Then, everything changed when the Omicron variant attacked. Only rewatching Avatar and researching all four elements kept us sane. But when Bad Astra needed a video, creativity vanished. 100 years passed, and on a live stream I discovered a new collaborator, a composer named Katie Shesko. And although her flute-playing skills are great, we had a lot to learn before we were ready to write any script. But I believe that you'll enjoy this mess. Water, or H2O, is a molecule with 2 hydrogen atoms and 1 oxygen atom. Water is necessary for all life on Earth, and is probably necessary for life in space, because it's a universal solvent, which can dissolve more substances than any other liquid. Water is also a heat sink, which means it absorbs heat. This is really important for temperature regulation, or keeping things hot or cold. Light can penetrate water. This means that energy from a star could get to life living underwater on a planet or moon or asteroid. Water also has a high surface tension, which means that depending on your size, water might look like a liquid or a solid to you. Water also has a high cohesion. Water sticks to itself, making it easier for life, like tree roots, to absorb water. Water also exists as a liquid in places where there's enough heat energy to support life. The region around stars where water can be in its liquid form is called the Goldilocks zone. Not too hot, not too cold. Just right for life. Earth has 4 layers. The brittle crust, which we live on. The mostly solid mantle, which makes up 84% of Earth's total volume. The molten outer core of liquid iron and nickel. And the solid, dense inner core. Heat variations in the core can cause movement in the mantle, which causes the solid plates of the crust to shift. Plate tectonics is the study of continental drift, or pieces of that solid crust moving around over the liquid mantle. This movement can cause earthquakes and volcanic eruptions in places at the boundaries between plates. At divergent plate boundaries, where the plates separate, molten rock or magma rises from the mantle and solidifies, forming new crust. Narrow rift valleys form, geysers spurt superheated water, and oceanic crust is created. At convergent plate boundaries, where plates collide, the edge of one or both plates buckles. In the ocean or on a coast, one heavy ocean plate subducts under the other, and a deep seafloor trench is created, along with a nearby volcano range. On land, one lighter plate rises above the other, creating a mountain range. A transform plate boundary, or two plates rubbing past each other, causes earthquakes when the plates slide past. All three of these plate boundaries cause earthquakes. Sometimes the plates get stuck on each other, and the earthquake happens when enough pressure builds up and the plates that were stuck in place by friction finally slide away, under, over, or past each other. Fire, or combustion, is an exothermic or heat-releasing chemical reaction. Hydrocarbons like wood, coal, and oil react with oxygen in the atmosphere to produce CO2, or carbon dioxide, and H2O, or water. Hydrocarbons and oxygen combine to form carbon dioxide and water in complete reactions. However, incomplete reactions where hydrocarbons and oxygen can come together and produce carbon monoxide or carbon and water can be deadly. Combustion reactions also produce heat energy, which is how oil powers your car and how coal plants can power an electrical grid. However, the CO2 produced by the reaction traps heat from sunlight in the atmosphere. This is called the greenhouse effect. The burning of hydrocarbons, or fossil fuels, on a large scale produces a lot of CO2, or carbon dioxide, which warms the atmosphere. Incomplete combustion reactions are dangerous, since along with water, they can produce carbon monoxide, a colorless, odorless, tasteless, and deadly toxic gas. It's important to always have a working carbon monoxide detector in your home. A flame can be many different colors, depending on the temperature. The flame you can see is the thermal radiation being given off by the heated soot. The hottest flames will burn blue. Cooler flames will burn white, then yellow, then orange, then red. But with some added ingredients, you can make flames even more colorful. Electrons orbit atoms in a set number of available states. Think of them like on stairs of a staircase. When an atom is heated, one of its electrons can get excited and jump up to one of the available higher states, or available higher stairs, before falling back down. When an electron falls back down to the lowest available stair, it releases light at an exact wavelength corresponding to the distance of the fall, or the distance between those stairs. Each element has a different number of electrons and a different set of distances its electrons can jump up and fall down. So think of every element having its own unique staircase. We know these stair distances by the light wavelengths emitted, or the emission spectra. These emission spectra, or staircases, are unique to elements like fingerprints are unique to humans. So, when barium is added to the flame, even though barium isn't part of the combustion reaction, the heat from that flame makes its electrons get excited, jump up a stair, and then fall back down, emitting green light and making the flame appear green. Air, or Earth's atmosphere, is 78% nitrogen, 21% oxygen, 0.9% argon, and 0.1% other gases like carbon dioxide, methane, water vapor, and neon. As you get further up, the atmosphere gets thinner. In fact, beyond around 8,000 meters or 26,000 feet above sea level, the air is too thin to breathe for a long time. Mountain climbers call anything above that the death zone. But altitude sickness can set in as low as 2,500 meters or 8,000 feet, since your body isn't getting enough of the oxygen it needs. Airplanes fly using the Bernoulli effect, a type of airbending. The tops of airplane wings are curved and the bottoms are flat. This forces the air to move quicker above an airplane's wing. Quicker air puts less pressure on the wing. So, the bottom of the wing receives more upward pressure than the top receives downward pressure. This difference in pressure is enough to lift the plane into the air and hold it above the earth. The atmosphere also has layers. The troposphere stretches from the surface of the Earth to 7 kilometers or 5 miles high at the poles and 15 kilometers or 10 miles high at the equator. The troposphere is the densest layer and contains 75 to 80% of Earth's atmosphere and most of the water vapor, dust, and ash. The stratosphere reaches up to 50 kilometers or 30 miles above the Earth's surface. The stratosphere contains the ozone layer. This high concentration of O3 molecules absorbs some of the incoming solar radiation, shielding life on Earth from harmful ultraviolet light. Above that is the mesosphere, which reaches 85 kilometers or 53 miles high. This is the layer where meteors burn up, creating shooting stars. The thermosphere reaches around 600 kilometers or 372 miles above the Earth. Solar radiation heats the upper regions of the thermosphere as high as 2,000 degrees Celsius or 3,600 degrees Fahrenheit. The exosphere is so far from Earth that gas molecules sometimes escape Earth's gravity, blending this layer with outer space. Where does the atmosphere end and space begin? Different scientists disagree because there's a smooth transition from the densest troposphere to the thin exosphere, blending into the void.
Bad Astra, to the stars, to the sky.